Good morning, students. So today we are starting with chapter 3. So let's see what we are going to cover in chapter 3. The title of chapter 3, Equilibrium of a Particle, the free body diagram, and coplanar force systems. Okay, what are the objectives? Draw a free body diagram and apply equations of equilibrium to solve a two-dimensional problem. Okay, so once we talk about statics, we talk about equilibrium, right? If you remember, we already talked about this in the earlier lectures. As once we talk about statics, then we consider that the body or the particle is in equilibrium, right? So that's what we are going to do. And once we have equilibrium, then there's no balance force on the body, right? Or on the particle. So here we are talking about particle, but overall it's any rigid body, any structure, any member. Okay, so once we have equilibrium, then there's no balance force. All the forces balance out each other and there's no balance force. All right, so first of all, let's talk about a free body diagram. What is a free body diagram and why do we need a free body diagram, right? So what is a free body diagram? A free body diagram is the one which shows all the applied forces on a particle, on a point, on a body, right? On any structure. So once we draw a free body diagram, then we come to know, okay, what are the forces acting on that point, acting on that particle, or acting on that rigid body, okay? And then we apply equations of equilibrium to solve that problem, to analyze that problem, right? Because whenever we have a problem, we have a statics problem in particular, then we have some unknowns, right? There are some forces which are unknown, there are some reactions which are unknown, which we need to find, which we need to determine, right? So by drawing a free body diagram and analyzing that free body diagram with the help of equations of equilibrium, we can find the unknowns, right? So that's what we are going to learn and what we are going to do in this chapter. Okay, so now let's move forward. Free body diagram for coplanar force systems. Okay, so first of all, what is a coplanar force system? So whenever we talk about two-dimensional space or a 2D problem, then we are talking about coplanar force system, right? We only have x-axis and y-axis. Just two coordinate axes. We don't have a z-axis because we are not talking about the third space, third direction, right? That's a z direction. So we are talking about 2D space. We are talking about coplanar forces or coplanar force system, right? If you look here in this figure, here we can say that it's only x and y, right? X-axis and y-axis. So there's no z dimension, there's no third dimension. So it's a coplanar force system, okay? So let's see what's written here. This is an example of a 2D or coplanar force system, all right? We already talked about this. If the whole assembly is in equilibrium, then particle A is also in equilibrium, okay? Now let's come back to this figure. So we can see there's this is a weight of 40 kg, mass of 40 kgs, right? Hanging down at point C, right? Then there's this hook at point A, right? This is the hook. So this is the hook at point A, and there are three cables, AB, AD, and AC, attached to that hook, attached to point A, right? And the upper two cables, they are attached at point B and point D with some supports, right? Let's not go into the details of the supports, because we are only considering the forces in the cables here. Okay, so we have these three cables and there's a mass of 40 kgs hanging down, suspended at point C, right? So now we are going to analyze this problem. But how we are going to analyze this problem? We will make use of a free body diagram. We'll make a free body diagram. We'll draw a free body diagram, and then we'll apply equations of equilibrium. right? We'll talk about equations of equilibrium in a minute, okay? Let's first focus on the free body diagram, okay? How to make a free body diagram, that's very important. You need to learn, you need to know how to draw a free body diagram, right? So this is a very basic system, 2D system, so we can learn how to make a free body diagram, right? Okay, let's move forward. To determine the tensions in the cables for a given weight of the cylinder, you need to learn how to draw a free body diagram and apply the equations of equilibrium, right? So that's what we have been talking about. We have already talked about that these three cables, AB, AC, and AD, so there is some force, there is some tension in these cables due to this weight hanging at point C, right? Due to this cylinder hanging at point C, okay? Now, if we want to find out, and if we want to determine the tensions in these cables, then we need to analyze this system. But how can we analyze the system, right? We need to draw a free body diagram, only then we can analyze the system, all right? And once we are done with the free body diagram, then what we need to do to analyze the free body diagram, we need to apply the equations of equilibrium, right? Okay, so let's move forward. Now, let's talk about free body diagram, okay? Free body diagrams are one of the most important things for you to know how to draw and use for statics problems, okay? So in any statics problems, we have to draw a free body diagram, right? In most of the cases, we need a free body diagram in order to analyze the structure, and to analyze any system, okay? Especially in statics, okay? Because we need to apply the equations of equilibrium, and to apply those equations, we need a free body diagram, okay? So this is a very basic concept, but the most important concept to learn how to draw a free body diagram, and then how to apply the equations of equilibrium, right? So you need to pay attention, you need to focus here so that you can learn how to draw a free body diagram, all right? Okay. Now, let's talk some more on the free body diagram. What is a free body diagram? It is a drawing that shows all external forces acting on the particle. So at the moment, we are talking about a particle. We are not talking about the whole body, right? So we'll talk about a particle, and then later on, we can do the same on a rigid body, right? So for now, let's focus on a particle, on a point, right? Particle, we can say at a point, right? Okay, so what is a free body diagram? It is a drawing that shows all external forces acting on that point, acting on that particle, okay? All right, so we already talked about this. Now, why do you need a free body diagram? To be able to write the equations of equilibrium, right? To apply the equations of equilibrium, we need to write the equations of equilibrium for that particular system, right? For that particular free body diagram. And then we can use the same equations to solve for the unknowns. We already talked about this, right? There are always some unknowns in the system which we need to determine, right? In order to analyze the system, okay? So by writing the equations of equilibrium for a free body diagram, we can use these equations of equilibrium to solve for any unknowns. All right, okay, let's move forward. Now, next thing, how do you make a free body diagram, right? What are the steps? So now, first step, imagine the particle to be isolated or cut free from its surroundings, okay? So that's really important. Now, this is the figure, this is the system which is given to us, right? Now we need to analyze this system, okay? Maybe we need to find the tension in cable AB or AD or AC. For that, we need to draw a free body diagram, right? So first step, to draw a free body diagram, and please remember, it's always good, it's always easier if you go in steps. So just remember these steps and go in steps to draw a free body diagram. So first step is to take the particle as isolated or cut free from its surroundings, right? So in this case, let's take this point A, right? So just take this point A or particle A and isolate it from the surroundings. Okay, so let's do that. So it is drawn here, but let's draw it again. Okay, so let's say this is the hook. Okay, so this is your point A. Okay, all right, so this is the first step. First step is done, right? Imagine the particle to be isolated or cut free from its surroundings. So essentially we are talking about point A here, right? Because all the forces are connecting to point A, right? All the cables are connecting to point A. So let's draw a free body diagram at point A, right? Now, we know that we have x-axis and y-axis. Let's draw those. So this is your x-axis and this is your y-axis, okay? So we have x-axis, we have y-axis, okay? All right, so we are done with the first step. Now, let's go to the second step. This step. Show all the forces that act on the particle, all right? So let's show all the forces that act on the particle, okay? So we have a cable AC, right? So you can say that, okay, this guy AC is giving some force, right? So let's apply some force here, or maybe we can say a tension force, right? So let's apply that, okay? So we can say FAC or maybe TAC, something, right? Now we have a cable AB at an angle of 30 degrees. So let's draw that. Let's say this is your cable AB. So this is your FAB, right? Okay. Now we have another cable AD. So let's draw that. This is your force FAD, or we can say TAD, right? So now we are done with the second step. We have shown all the forces acting on that particle, acting at point A, right? So there are three forces acting at point A: FAB, FAD, and FAC, right? Now, there are some active forces, there are some reactive forces, right? Active forces, they want to move the particle. Reactive forces, they tend to resist the motion, right? So in this case, in this system, FAC is the active force, right? Because the cylinder is hanging down. So it's creating a tension in cable AC and in the whole system, right? So it's trying to move the particle, right? And then what are the reactive forces? FAB and FAD are the reactive forces, right? So we are done with the second step. Now, third step, identify each force and show all known magnitudes and directions. Show all unknown magnitudes and directions as variables, all right? So we already done that. We already did that in our second step. So we, represented these forces with FAB, FAC, and FAD, right? So here they have done FB, FC, and FD, but it's the same thing. It's just a matter of understanding, right? So you can say FB or FAB, this is one the same thing. FAC or FC, again one and the same thing. FD or FAD, again is the same, right? Now there's an angle given, so mark that angle 30 degrees. Okay, so now our free body diagram is complete. Now, next thing, what are the known forces, right? So we know that this cylinder at point C is hanging down. So this is creating a tension in the cable AC, right? So we know what is the force FAC, right? Or FC. So we can just find that, right? How do we find that? We can just use weight equals mass times gravity. So mass is 40 kg times gravity, which is 9.81. So 40 times 9.81, we'll get FC equals 392.4 newtons, right? So we know how to find that, right? So we know FAC, and there were three forces in the free body diagram, FAB, FAC, and FAD. Out of those, we know what is the value on the magnitude of FAC, right? So what are the unknowns left? So there are two unknowns left, FAB and FAD, right? So now we can move further and try to find the unknown forces, right? So now we need to find FB and FD, right? We already know this guy, FC, okay, which is 392.4 newtons, okay? Since particle A is in equilibrium, the net force at A is 0, okay? So what does it say? As we are dealing with static problems, and we know that this particle or the system is in static equilibrium, so once this whole system is in static equilibrium, then point A is also in static equilibrium. And once point A is in static equilibrium, then we can just say that the net force at point A or particle A is 0, right? So what we can say that FB plus FC plus FD equals to 0, right? Because there's no balance force, right? There's no movement. It's static equilibrium, right? Or we can just say sigma F equals 0, right? Sigma F equals 0, summation of forces equals 0, because there's no balance force, right? So now let's talk about equations of equilibrium, right? So we know that we already talked about that sigma F equals 0 because there's no balance force, right? So once we say that sigma F equals 0, now we can convert it into X and Y components, right? So let's convert that into X and Y components. Sigma Fx times I plus sigma Fy times J equals to 0. Right? Because we have summation of forces equals 0. So we can also say that summation of forces in X direction equals to 0 and summation of forces in Y direction equals to 0, right? So these are the two equations of equilibrium for two-dimensional space, right? 2D space, okay? So what are the equations of equilibrium? Sigma Fx equals 0 and sigma Fy equals to 0, right? You have already learned that in your physics course, right? So this is just a repetition. Okay, so sigma Fx equals to 0, which means that all the forces acting along x-axis in the direction of x-axis in the x direction equals to 0. So there's no balance force in x direction. And similarly, sigma Fy equals to 0. What does that mean? That means that all the forces acting in y direction along y-axis cancels out each other, balance out each other, and there's no balance force in y direction, right? So that's why summation of forces in y direction equals to 0. So these are two scalar equations of equilibrium, and we can use these, we can apply these to any system to find out the unknowns, right? But again, the main thing is that we have two equations, right? So since we have two equations, then we can only have two unknowns to be solved, right? So we can solve any system with two unknowns with the help of these two equations, right? If we have more unknowns, then we cannot solve with these static equations, right? So we can solve any system with two unknowns with these two equations of equilibrium, right? Okay, let's move forward. All right, so this is the same system which we already saw earlier. This is the same free body diagram with FB and FD, and FC is known. So FC is known and two forces are unknown. There are two unknown forces, FB and FD, which we are trying to find by applying equations of equilibrium on this free body diagram at point A, right? Now we can write these scalar equations of equilibrium, right? So let's write down the scalar equations of equilibrium. Let's first focus on this guy. Summation of forces in x direction equals to 0. Now, what is this guy? Let's talk about this guy. So once we want to apply this summation of forces in x direction equals to 0, or sigma fx equals to 0, then we need some sign convention, right? So we use this sign convention that rightward forces are positive, right? So we use this sign convention, right, to apply this equation of equilibrium, right? So as we can use any sign convention, right? But then we have to be consistent with that sign convention. Now, mostly all the books and mostly all the scientists, they use this sign convention for sigma fx equals to 0. So because the x-axis is positive in the right direction and negative in the left direction, so that's why they take rightward positive as the sign convention for sigma fx equals to 0, right? So now all the forces acting rightward will be positive, and all the forces acting leftward will be negative, right? So now we can apply this equation, sigma fx equals to 0. So let's see, how do we apply this, right? We apply this in this fashion. Now, come back here, come back to the free body diagram and see what forces are there in the x direction, right? So we know how to resolve the force into components, right? So let's resolve this FB into two components, right? So this is one component, and this is the other component, right? So this guy is FB times cosine of 30 degrees, right? And this guy is FB times sine of 30 degrees. Okay, so we resolve this force FB into two components in order to apply the equations of equilibrium, because we need either the forces in x direction or y direction, right? We cannot have FB in its original state, right? So that's why we need to convert it or resolve it into two components, right? So now we can say that this FB times cosine 30 is in x direction, right? And it's acting rightward, so it's a positive, right? So that's why we write this FB times cosine of 30 degrees. And then if we see what is the other force acting in x direction, so we have this FD, right? And it's acting towards the left direction, negative x direction, so that's a negative, right? So that's why we'll say negative FD equals to 0. So we had only these two forces in x direction, right? So that's how we can write this equation. Let's call it equation 1. So this first equation, equation 1, is the summation of forces in x direction equal to 0, because there's no balanced force, right? So both of these forces will balance out each other. All right. Now let's talk about sigma Fy. Okay. Let's talk about this guy. Sigma Fy equals to 0, right? Summation of forces in y direction equals to 0. Okay. So again, we need to focus on the sign convention, right? So this is the sign convention, upward positive. And please remember that we need to show these sign conventions whenever we are solving any statics problem, okay? For that matter, any mechanics problem, right? So here we are talking about statics, so let's restrict ourselves on into statics, okay? So upward positive, and again, we can take any sign convention, but then we have to be consistent. So let's take this sign convention and be consistent with this, right? So because upward is positive y direction and downward is negative y direction, so that's why we take this sign convention and we say that upward forces are positive, okay? Now let's talk about sigma Fy. How do we write sigma Fy equals to 0? Now let's come back to the free body diagram and see what forces are acting in y direction, right? So this is y force, and this guy is also y force, right? So we have these two forces in y direction. FB times sine of 30, which is acting upward, so it's a positive force, right? So that's why we write this FB times sine of 30, right? And then this guy FC, which is 392.4 newtons, is acting downwards. So this is a negative force, right? That's why we write this negative 392.4 newtons, okay, equals to 0. So that's how, let's call it equation 2. So this equation 2 is sigma Fy equals to 0, okay? So we get this equation 2 by applying summation of forces in y direction equals to 0. Now, if you look at these two equations, so what are the unknowns? FB and FD, right? So two unknowns and two equations. So we know that if we have two equations and if we have two unknowns, then we can solve those two equations to find the value of two unknowns, right? So we can do that. Let's do that. So from equation 2, we can just find out the value of F sub B. So this is F sub B, which is 785 newtons. It's a positive, which means that it's acting in the right direction, rightwards, right? And then if we put FB in equation 1, then we can find out the value of FD, which is 680 newtons, right? And that's we get a negative number, which means that it's acting on the left side, right? Towards the left side or leftwards, okay? So that's how we apply the equations of equilibrium after we draw a free body diagram to solve for the unknown forces, right? So I hope it makes sense and you are able to utilize this concept for further statics problems, okay? Now let's move forward and let's do another problem, okay? The more problems you do, the more practice you do, the more confident you are, right? More practice, more confidence, right? So let's look at this system. So again, that's sort of same system, three cables, AC, AD, and AB, right? The angles and the triangle ratio is given for AC and AB. There's a box at point D, which is hanging down, and the weight is 550 pounds, okay? So this 550 pounds weight is creating some tension in these three cables, right? Okay, let's come back to the statement. The box weighs 550 pounds and geometry is as shown. All right, we already saw that. What we need to do? We need to find the forces in ropes AB and AC, okay? Because we already know what is the force in cable AD, right? That is the weight, 550 pounds, okay? All right, so we need to find AC and AB. Since we have already only two unknowns in this system, we can draw a free body diagram at point A and we can find out these two unknowns by applying equations of equilibrium, right? Again, remember, if we have more than two unknowns, then we cannot use equations of equilibrium, right? Okay. All right, so let's move forward. What's the plan? What are the steps? First step, draw a free body diagram for point A. Why point A, right? That's also a question. Why point A? Why not point C? Why not point D? Why not point B? So, because every point is in equilibrium, right? Point C is also in equilibrium. Point D is also in equilibrium, because once we say that the whole system is in static equilibrium, then every point in that system is in static equilibrium, right? So why point A, right? Just think about it. Why point A? Because all the forces, all the cables are intersecting at point A, right? They are originating from point A, we can say that, right? So point A is the point of intersection of all these forces, all these cables. So that's why if we make a free body diagram at point A, we can see all the forces. We can apply all the forces on that free body diagram, right? And then we can apply equations and we can find out the unknown forces, right? Now, if we draw a free body diagram at point C, let's suppose, right? Then what unknowns do we have? What forces do we have at that point? We have FC, right, or FCA. Okay, so can we find something? No, right? So that's why you need to find out, you need to determine some point at which we have all the forces acting, right? So once we have all the forces acting on one point, we should take that point and draw the free body diagram. So in this case, let's take point A and draw a free body diagram. Okay. Now we already know how to draw a free body diagram, so let's not go into all these simple details. So we took this point A, right? This is your point A, this guy, and step one, just isolate this point from the surroundings. So let's suppose that we don't have these forces, we just have this point A. So just draw point A. Then step two, apply the forces, right? So we have three forces, FC, FB, and FD, right? FD is the active force and FB and FC are reactive forces, right? So once we have these three forces, then step three, we need to see what is known, what is unknown, right? So in this case, we already know what is FD. We have a weight of 550 pounds, so FD equals 550 pounds, right? So we already know this. So we have one known force, and FC, we need to find, and we also need to find FB. And then we have this angle of 30 degrees, and we have this triangle ratio, right? 3, 4, 5. Okay. So with this, we are done with the free body diagram. Now we can just apply the scalar equations of equilibrium at point A and solve for the unknowns, right? So again, let's look at this sigma fx equals to 0. Let's look at this. First of all, sign convention, very important. Whenever you do some homework, exam, quiz, or anything, just don't forget to write the sign convention, right? Always write the sign convention and then start writing the equation. Okay, so positive rightwards, x forces, which means the forces acting in the positive x direction are positive, in the negative x direction are negative. Okay, now let's write down sigma fx equals to 0. So let's see what forces do we have in x direction, right? Now, how many forces do we have in x direction? We have an x component of FC, we have an x component of FB, right? So what are these two components? FC and FB, right? So let's talk about FC. What is the x component? FC times 4 by 5, right? And it's acting rightward, so it's a positive force, right? So FC times 4 by 5 is a positive force. And then we have a component of FB, which is acting leftward, right? FB times cosine of 30, which is a negative force, right? So negative FB times cosine of 30, right, equals to 0, because we know that there's no balanced force, and that's how we write this equation of equilibrium in x direction. All right, so we are done with this. Let's say equation 1. All right, now let's go to the second equation, sigma fy equals to 0. All right, again, sign convention, very important. If you don't write this sign convention, then there's no meaning. Nobody knows what you are doing, right? Because you need to tell them that, okay, I'm using this sign convention, I'm taking all the upward forces positive, I'm taking all the downward forces negative, right? And then you write this sigma fy equals to 0 equation. Okay, now let's go back to the free body diagram and see what are the forces acting in y direction. So if you look at the free body diagram, how many forces in y direction? We have FD acting downward, a negative force. Then we have a y component of FC and a y component of FB, both acting upward, so they are positive, right? So we have three forces. So let's write these three forces here in this fashion, right? So FB times sine of 30, which is a positive force, FC times 3 by 5, which is a positive force, and negative 550 pounds, which is a negative force, right, acting downwards, equals to 0. So this gives us equation 2 for summation of forces in y direction equals to 0, right? Okay, now we can solve these two equations to get the value of these unknowns, right? Because again, let's say that we have two equations, right? We have two equations and we have two unknowns, right? So we have the unknowns which we have are FB and FC, okay? So we can just find out by solving these two equations the value of FB and FC, right? So I'm not going into the details of solving these two equations because you already know this simple math, right? So FB equals 478 pounds and FC equals 518 pounds, right? Okay, so that's how we are done with this problem and finding out the unknown forces in the two cables, AC and AB. And we denoted them by FB and FC, right? So that's how we are done with this problem. Okay, I hope you got something out of it and we'll be able to solve further problems. All right, okay. Now let's do another problem, okay? Okay, let's look at this system first. So this is this given system. Again, it's a two-dimensional system, so only two coordinate axes, x-axis and y-axis, right? So this is a coplanar force system, right? Now we have more number of cables, right? So let's go through the statement. The mass of cylinder is 40 kg and geometry is as shown, right? Okay, and we need to find the tensions in cables DE, EA, and EB, okay? So DE, EA, and EB, right? So we need to find these three unknowns, right? So let's talk about this. Okay, what's the plan? Draw a free body diagram for point E. Okay, so let's draw a free body diagram at point E because all the forces are intersecting at point E, right? Apply the equations of equilibrium to solve for the forces in these cables, right? So FDE, FEA, and FEB. Okay, let's move forward. Okay, now let's draw a free body diagram at point E, right? So again, we isolate point E from the surroundings. So we'll just draw this point E initially in first step, and then we'll move forward and we'll apply the forces, all the forces acting at point E. So what are the forces acting at point E, right? So as these are tensions, so let's call them with a capital T, right? So TEB, TED, and TEA, right? So we have these three forces, but as we know that there's a mass of 40 kg hanging down or suspended at point C, right? With a roller at point B, with a pulley at point B, right? So we already know what is TEB, right? So TEB is equal to the weight of the cylinder, right? So 40 times 9.81, right? So that is the force in the cable EB. So we already know this guy, TEB. And we have two unknowns. We have this TEA unknown and we have TED unknown, right? So again, after drawing this free body diagram, we saw that we have two unknowns and we have one known force, right? So once we have two unknowns, we can solve the system because we have two equations of equilibrium in two dimensions, right? Okay, so after this, we can just apply equations of equilibrium on this system, right, on this free body diagram. So let's apply equations of equilibrium. Sigma fx equals to 0, sign convention, very important. What are the forces in x direction? We have two forces. we have TED, which is a negative force, right? And we have a positive component of TEB, right? X component of TEB, which is a positive force, right? So we have negative TED, and then we have a positive TEB times cosine of 30, right? And TEB, we already know the value, 40 times 9.81, right? Okay, equals to 0. So we are done with equation 1, which is the equation for sigma fx equals to 0. Okay, all right. Now let's go to the second equation, which is sigma fy equals to 0. Okay, so first of all, again, the sign convention, which is a must, upward positive. Sigma fy equals to 0. Now, how many forces in y direction? We have TEA and we have a component of TEB, right? Y component of TEB. So we only have 2 forces in y direction, right? And the y component of TEB is acting upward, so it's a positive, right? So this is TEB times sine of 30 degrees, which is a positive force. Then TEA is also a y force and it's acting downwards, so it's a negative, right? So negative TEA equals to 0. So this gives us equation 2 due to summation of forces in y direction, right? Okay, now we have these 2 equations and we have 2 unknowns. So just solve these 2 equations and get the value of these 2 unknowns, right? So if you do that, you get TED equals to 340 newtons and TEA equals 196 newtons. All right, so that's how we are done with this problem. Okay, all right, so now let's do another problem. Okay, let's do another problem. Let's look at the system. Now we have more cables. Yeah, 1, 2, 3, 4, 5 cables. AC, BC, CD, DF, and DE. Okay. What's given in the statement? The mass of the lamp is 20 kg and geometry is as shown. Okay. So this lamp at point F, it's hanging down, right? So the mass is 20 kg. Okay. And what we need to find the forces in each cable. Okay. Now that means we need to find 1, 2, 3, 4, 5 forces. Okay. Now, if you just look at this system, how can we find 5 forces with 2 equations of equilibrium? That's a problem, right? But there should be some way. Rather, there is some way, right? So let's see what is that method. How do we do that? Okay. So what we do, we do this problem, we analyze this problem in parts. Okay. Since if you look at the system, we have this point D, right? And we have this point C. So we'll take them on one by one, right? So let's see if we take point C, right? And we draw a free body diagram at point C. Just assume, just imagine, right? How many unknowns do we have? CD, CA, CB, or we can say FCD, FCA, and FCB. We have 3 unknowns, right? There's no known force. Can we apply equations of equilibrium? Because we have 2 equations and we have 3 unknowns. So we cannot solve, right? But if you look at point D, if you draw a free body diagram at point D, right, and apply statics equations of equilibrium, then can we solve it? We have 3 forces, right? But out of those 3 forces, FDF is known force, right? So we have 2 unknown forces, FDE and FDC, right? So once we have 2 unknown forces, then we can solve the system. So this is how you make out where to draw a free body diagram first if we have a little complicated structure, complicated system, right? So in this system, we'll start with the free body diagram at point D. We'll find out FDE and FDC, and then we'll go to the free body diagram at point C. And then once we draw the free body diagram at point C, then we already have FCD as a known force. So we only have two forces, FCA and FCB, as unknown forces, which we can analyze, right? So that's how you do such kind of system. Okay, so let's look at the steps. Draw a free body diagram for point D, apply the equations of equilibrium at point D to solve for the unknowns FCD and FDE. Okay, then after doing that, we know FCD, so we can repeat this process at point C, right? Apply the equation and find out FCA and FCB. Okay, so we already talked about this in detail. Let's go over to the solution. Okay, all right, so now let's this is the same system. On the right side we have the free body diagram at point D, right? In the center we have point D. So first step, we need to just draw that point D, right? In second step, we draw the applied forces. So what are the forces? We have three forces: FDE, FCD, and the force at we can say FDF, which is the weight of that lamp, right? What is the weight? It's 20 kg times 9.81, which is the gravity, so which will give us the weight in newtons. Right, so we already know what is FDF. That is the weight of the lamp. Okay, so we have two unknowns. We know this angle of 30 degrees, which FDE makes with the x-axis. So we can resolve this into x and y components, and we can apply equations of equilibrium. Right. So let's see, how do we apply equations of equilibrium? Right. Upward positive, sigma Fy equals to 0. How many forces in y direction? We have two forces, a component of FDE and the weight W, right? So FDE times sine of 30, positive force, negative 20 times 9.81, which is a negative force acting downward, equals to 0. Okay, so this is your equation 1, right? Sigma Fy equals to 0. Now, sign convention, rightward positive, sigma Fx equals to 0. So how many forces in x direction? A component of FDE and FCD as a whole, right? W is not involved because that is a y force, right? So we have two forces, FDE times cosine 30, which is a positive force because acting rightward, and a negative FCD because this is acting leftward, equals to 0. So this gives us our equation 2. Now, if you look at these two equations, we only have two unknowns, FCD and FDE. So just solve these two equations and find the value of FDE, which will be 392 newtons, and FCD, which is 340 newtons, right? So that's how we are done with this. We already knew this. We are done with this. We are done with this. And now we can make a free body diagram at point C, knowing FCD, right? And we can find out FCA and FCB, right? Okay, let's move forward. Now let's draw a free body diagram at point C. Okay, so by now I think we should be clear how to draw a free body diagram. So let's draw that. Let's draw a free body diagram at point C. We have three forces, FCD, which is 340 newtons, FAC and FBC, which are unknown forces. Okay, moving forward, applying the equations of equilibrium at point C, we get this sign convention for sigma Fx. Sigma Fx equals to 0. How many forces in x direction? We have, if you look at the free body diagram, we have three forces in x direction. We have FCD, we have FAC, a component of FAC, and the x component of FBC, right? So we have a 340 newtons positive force acting rightward, and both of the other forces are negative, acting leftward. So F is FBC times sine of 45 degrees, and FAC times 3/5 equals to 0. So this gives us our equation 1. Okay. Then sigma Fy equals to 0, upward positive, sigma Fy. So now we will do summation of forces in y direction. Okay. So let's do summation of forces in y direction. Now let's come back to the free body diagram and see how many forces are there in y direction. We have a component of FAC, we have a component of FBC. Okay, so FAC times 4 by 5 and FBC times cosine of 45. Right? FAC times 4 by 5 is positive because it's acting upward. Right? And FBC times cosine of 45, the y component of FBC, it's a negative force because it's acting downwards. Right? Okay, so this will give us our equation 2. So now again, if you look at these two equations, we have two equations and we have two unknowns. What are the unknowns? FBC and FAC. Just solve these two equations and find out the value of these two unknowns, right? So we get the value of these two unknowns. FBC equals 275 newtons, FAC equals 243 newtons, right? So that's how we are done with this problem, finding out the unknowns in all the cables, 5 cables. So in first look, anyone can say, okay, we have 5 unknowns. Oh wow, how to draw the free body diagram or how to find these 5 unknowns, right? Because we only have 2 equations, right? So it makes sense, right? Because we cannot analyze the system in one go, right? Because we cannot find 5 unknowns with 2 equations. But as we did this problem, so we found out that we can draw, we can do this problem in parts, right? First analyze point D and then analyze point C, right? And then in this, with this method, we are able to solve this problem and find out the value of all the unknown forces and all the cables. Okay, all right, so we are done with this. Now, we were essentially talking about the 2-dimensional force systems or the coplanar force systems, right? Only having 2 dimensions, x and y. Now, if you talk about 3D force systems, 3-dimensional forces or 3-dimensional space, then we have to add the z direction, right? X, y, and z. Okay, so we need to, if we need to analyze 3D system, then what are the equations? Okay, so first of all, free body diagram. We need to draw a free body diagram by establishing a suitable Cartesian coordinate system, label all the force vectors, assume the direction of the unknown forces. So it's a little complicated. So we are not going to do any problems on 3D force systems. We're just having a basic knowledge of 3D force system, right? Okay. So what are the equations of equilibrium? We just add sigma fz equals to 0, right? And that's the only thing. So for 3D force system, for a particle, for a point, we have 3 equations. We have sigma fx equals to 0, sigma fy equals to 0, and sigma fz equals to 0, right? And that's all of these 3 are vector equations because we need to use Cartesian coordinate system because we are working in 3D space, right? So sigma fx times I, sigma fy times j, and sigma fz times k equals to 0, right? So this is the only difference between 2D systems and 3D force systems. Okay, so we are not going to do any problems on 3D force systems. This was just to tell you the difference between the 2D force systems and 3D force systems, right? In 2D force systems, we have 2 equations, sigma fx equals to 0, sigma fy equals to 0, and for 3D force systems, we just add sigma fz equals to 0, and then we solve this problem. Okay, All right, so with this, we come to the end of today's lecture, and I hope you are able to get something out of it, talking about the equations of equilibrium, talking about the Freebody diagram, and talking about applying the equations of equilibrium to a Freebody diagram and finding out the unknown forces in a system. All right. All right. Thank you so much, guys, and see you next time.